Or in pending, what does it mean? Okay, sorry. Sorry, the red thing I thought it was done. Okay, anyway. So we are doing UDP, it's a transport layer protocol. Same thing, notion of port to identify application layer service. And the primary purpose is only that provide multiplexing, demultiplexing application. So everything that comes to the same IP, based on port, we give it to different applications. But it does none of the other things. So there is, it's connectionless, so no connection setup termination. So your demultiplexing is basically done on the basis of one input. You still have a socket motion, IP port. Okay. Only thing for TCP, multiplexing or demultiplexing based on connection. So this pair and the other pair connecting with it. Here there is only one. And then that is still in the lab also. So if I open a UDP server, any client can send it any kind of thing. As long as on the server end. And it's a message oriented protocol, not block oriented, sorry, byte oriented like TCP. So these all things I think you know from the lab already, just a little bit of recapitulation. So everything that we make in one send call will be same its entirety, provided we did not give something other than the send buffer size. Similarly, on the other side, it will be stored as a single entity and the client can read it in one go, provided the client again has given sufficient buffer size. Otherwise, it will just be truncated and lost. And data terms can be lost, arriving in different order from the order send everything. So almost, just have everything in TCP other than the multiplexing, demultiplexing. Just say no to everything else. No flow control, no error control, no condition detection. So only multiplexing, demultiplexing. The idea is that it's very simple and fast. So there is no complex operation, there is no state information. The moment you have a connection, you have to maintain lots of state information, things like this window size, connection windows, which days you are in, blah blah blah. Okay? It's nothing, you get the packets, demultiplex, and it's the proper software. Similarly, when you send, you just send it out, forget about it. It reaches, it doesn't reach. No retransmission, no acknowledgement, nothing. Message format, very simple, 12 byte header, source code, destination code, length, checksum data. Only thing that checksum is the same as a TCP. So you put a pseudo header in front of it, defined exactly in the same manner. Then the UDP header, then the UDP data, and you take a checksum over the entire. Hardly anything to do with this. I think this is all the same threads, nothing much to do. It's very widely used because you don't need reliability for many of the protocols. Here is the classic example. CNTP is the other one, by which you all synchronize your clock basically. So you ask the server for a time basically, and the server gives you the time. So you don't need reliability. Either you get it or you don't get it. If you don't get it, then you will ask for it again. So you see, when I say you ask for it again, DNS for DNS, you ask for a IP for a name, and if it does not come back, somebody has to wait and ask for it again. Responsibility is to start the application. Similarly, this, I don't know if you heard about this protocol, simple network management protocol. Heard about it? So all your switches in your hostess and gone. Okay. You can see in CIC and monitor almost everything in this. So you can see what traffic is going on now. For high-end switches, not the kind that I will show you today, you can actually see. Let me know when you are finished. Let me know when you are finished again. Don't talk in a minute. You have a question you ask me. Okay? Yeah. So for hardened switches, you can see everything. You can actually ping for its temperature inside and so on. So you know the temperature is rising and so on. Everything you can monitor. So the protocol that makes it happen is what is called a simple network management protocol. It's a very simple thing. You have a client sitting on your CICN, the client software, SNMP client, and there's SNMP server running on the switches. And there is an agreement that you what are the formats in which I'm going to ask for, what parameters I can ask for, and so on. So the client sends a request, the server uses one of the temperature sensors and so on to get the data and then send it out. So this is what, if you recall, somewhere when we were talking about Ethernet, I said a managed switch. Unmanaged switch and managed switch. The managed switch is one which runs SNMP server interface. So I can manage it remotely. I can configure it remotely and so on. Very similarly, I've already gone through it, the distance vector routing protocol. DHCP is something that we are going to do probably today. Let's see. And many other well-known applications. Basically, see, if you look at DNS, DHCP, etc., you will see you are running a local LAN. In a local LAN, the chance of drop is anyway. The chance of drop is anyway low. You don't want this guy to start doing all the connection and everything just because you are going to ask for one. So one is it's local. The other interesting thing about these protocols, if you think for a second, we never did DNS concurrent servers. Okay? We never did anything complicated with DNS. So DNS is typically used for DNS client servers. It's like a one-time transfer. Because if you have to go twice, saying I sent you something, you reply that. Based on that, I sent you something. Then you have to remember what I sent you already. That is not a standalone request, it is something in the context of the earlier exchange that has happened. Okay? That is key. And you does not mention anything. The server just sits there, one thing that comes, does something, forgets about it when it sends the response. So there's a lot of such protocols which require just this one round of transfer. DNS and cascade. So just wanted to show you that there is nothing much to talk about UDP. As I said, it's TCP minus most of the things, but still it's very popular because it's simple and fast, and lots of them don't need that reliability in order and all those things. So that's all about TCP and UDP. Okay, but this is the other thing that I mentioned in class. See, I said RAID, for example, or DHCP, for example, is going to work on top of UDP. Now, as per my layering, on top of UDP, this transport layer is the application layer. So these are like common questions to confuse you during while you are interviews and so on. So is DP application layer protocol? Is DHCP an application layer protocol? Because it's working on top of transport layer. What do you think? DHCP must have heard, right? You get the IP address to DHCP. We'll see how you get that today. But do you think it's an application layer protocol? It's an application? No, right? This is what I was pointing out. Even though the layering basically is a nice theoretical concept, okay? Mostly works, but we kind of break things that different thing, which is not exactly fitting this clear layering interface, lower thing which should not need anything to another one and so on. I'll give you an example, pseudo header. When you compute the pseudo header, you need the IP address. Okay? But you're not supposed to know the IP address. IP address is supposed to be stripped off and given to the transport. Please. So just remember that these are, it's not great things, but sometimes you may get questions in interviews and drive us to kind of confuse you. So we'll stop this, and so nothing much to talk about here, and we'll start with DNS. So how do you DNS works? Clause of DNS, I say www.google.com, I get a bunch of IP addresses. How do you think it works? Systems things I told you from day one. Okay. And normally, if you start the day one on an offline class, we have a much wider discussion on it. Okay? You have to kind of try to explain things around. You will not be able to explain fully. Okay, but all the answers are there, and you are extremely bright boys and girls. So it's to start asking the questions, we find the answers. So how does DNS work? We use DNS. What will happen if I type www.google.com on my browser? What's the first thing that happens? Knowing. That is the first step to know. How does it actually? How do that is the purpose of DNS. See, once you get the IP address, DNS is over. Okay, but how do you get the IP address? Magically from where?
There is a predefined service which is known, which will provide you with it.
Right.
As its own IP address.
So, fine. So, who are my predefined?
Internet service providers provide DNS services.
So, do you think for everything? Okay, fine. So, your basic notion of the design that somebody has to provide has to be a DNS server. Okay. First thing is that you have to know the IP of the DNS server. So, my next question would be to how do you get the IP? But let's leave that question aside for a second. Okay. Then, so where should that? If it's in the ISP, it's a good thing. Okay. Then so think about BSNL. BSNL gives service to so many people. If all your things goes to the BSNL's DNS server, always, okay, that doesn't seem like a good design, right? So what do you do like this? Fine, you have a cache, good, okay. But other than that, see, I set up a machine. Okay? Because what you just say is what used to happen earlier, not in the ISP, very funny. So, suppose I install a new machine, some website, local website or something. Now that I will give it a name because you are not expected to know its IP address, right? But it will have an IP address ultimately. Every access is by an IP address ultimately. So, how will people know about this? Do I have to go to BSNL server and say, put this name versus this IP mapping in your server? But everything I have to go to BSNL? No, right? So, who will I go to? Actually, so motivation for DNS is very simple. Ultimately, everything has to work with IP address, but an IP address is hard to remember. They keep on changing also. Okay. So users should not have to remember IP addresses. Okay. Very old days, I don't know if you heard about a file called hosts.txt. Anybody heard the name? Okay. In Linux systems, you will have a hosts.txt file, local. So you can actually do this thing on your local machine. But then, you see, local machine means when you type this thing in the source that it has to come on the local machine, then you look up the local. But then other people will not know. Okay. So in the very old days, early days when there were not this many machines involved, there was a single server sitting in University of Southern California. Okay, with the kind of the master host.txt file for the entire. So just like you said, I have to go get the ISP. If I install a new machine, I have to force a USC that I have done. Okay, there is a process, USC will update that, and then periodically, everybody will download that host.txt. Okay, so one master copy, multiple secondary copies, read-only copies. Okay. Obviously, that works for some time, that does not stay. Okay. So this was what is called a flat namespace. You can name your to anything. There was no something dot something dot something dot something. Okay. So if you go to a single entity, the single entity will find out if there is a conflict or something. Somebody has already used the name. Then it will say no, use some other name, and then you will send the request again, and so on. So there is no conflict and so on. Okay. But makes the host name file too large as the internet view. And the entire thing is completely unmanageable to be practically obvious. Okay. But again, you have to think about this thing that many of these things that you have studied were developed in the 80s. Okay. When the net was not this big, net was slow. Okay. And then things exploded. When things exploded, as I told you, you cannot just suddenly say, no, let me stop doing what I was doing. Okay, I will do this next big thing. Because by that time it has played to so many things that you cannot expect everybody to think. So whatever you do, there has to be lots of updates. DNS has one of the largest number of RFCs that I know. So you keep on adding features and so on, so that you can update versions. But you always have to worry about, being an old client should be able to connect to you. You cannot say suddenly that this will not be after this day, nobody will be able to connect. So anyway, this was doomed to fail. So you had what is called a hierarchy character names. So these www.google.com and so on and so forth. These dot things. You break the complete namespace. You think about the set of all possible names. Okay? And you break them up into what are called domains. And then the domains will get broken up separately into subdomains and so on and so forth. Okay? And what we will do in terms of that, who will do so that my ISP server does not get clogged, okay, is that I will delegate processing for name resolution within machines of a certain domain to somebody in that. I will just let the rest of the internet know that that server is responsible for identity. You go ask. Okay? Rather than everybody registering for every application you register machine somewhere. So that's what DNS is. It's a naming system for the internet. It's a hierarchical naming schemes. Specifies the name resolution mechanism which we do. But the other thing that you don't know probably is using DNS is very, very powerful. So far, most of your notion of DNS is to get an IP address of a machine corresponding to a name. Okay. I can get many different things. For a domain, I can know who is the mail server. I want to send mail. How do I know what's the mail server? I can know who is running the telnet service. Which machine is running the telnet service. Provided the other party wants to do. They have to advance. Okay? But there is a mechanism inside DNS, okay, by which I can know almost every machine thing out there. And I will show you examples. Web server, etc. See, Google has so many machines. How do I know which one is the web server? That's the one that should come back to. Similarly, www.google.com. It cannot be one machine. Okay? Now it's much more complicated than what I'm going to say. Okay? If you come next week, I'll try to show you a little bit about what happens in the backend. But at the very least, what I want is www.google.com to have 10 different machines. And 1,000 clients connect, they should get 10 different machines for the load gets. So how do I do that? How do I have one name and get 10 different IPs and different names? So there's a notion of a type with each name in the inside DNS, which says what is this name, which client does it correspond to? Okay, I'll give you examples. Just know right now that is. So for example, when it says csc.itkgp.ac.in, it can mean many things. It can mean just a domain. It can mean the name of machine. It can mean the name of the web server. It can mean the name of the mail server. It can mean the name of the one that is running the service in csc.itkgp. Same name can mean many things, and I will use the type field to distinguish what it means. I'll give you examples. So large number of RFCs. It's my duty as a teacher to kind of point you out to them. It's your duty as student to ignore. Okay, I'm sure that none of you have opened a single RFC, right? That's it. At least the word RFC is not, they keep on saying it again and again and again. The word RFC sticks in your mind. Okay. So DNS names. It's a complete namespace and tree of domains. Okay. So this is where I use the board. So now I move here and I don't have a chalk and duster. But I think it's easy to understand. Okay? So think of a tree structure. Your root, what should be the name of the root? What do you think? Land? Who's to get land? So root has the name dot. Actually, all the names that you see www.google.com, it's a complete name. It's actually www.google.com. We don't just specify because the browser comes from. If you say www.google, okay, and nothing else after that, that means there's a default or something that I'm doing. So now itkgp.ac.in machine, I can configure it as a CSV. When the browser queries the DNS, it will automatically get itkgp.ac.in. And it has a CSV dot, it's not going to fail. Now to send it to CSV dot, okay, and then it's going to fail because there is nothing but CSV. So you have dot at the top, then you have the com, edu, all those things that you see. And then country specific things. We have IN for India, we have for Korea, and so on. Okay? Lots of them. And these are what top level domains, TLDs. And the same organization that I talked about which manages the IP address space, also manages the top level. So you cannot just go and say suddenly the IP at the top level domain name for each. That's not possible. And then they will delegate the management to various entities. I'll explain what delegate means. And domains from the third level are managed by local operators. Local operators in the organization themselves. So I cannot direct TLD, I cannot say .ag. Okay. But if there is a .in, I can add .ac.in, .in, and so on. So this for ac.in, the local operator is Indian address, for example. If I say google.com, then the local operator is Google. And then the delegation is recursive. So once ERNet adds ac.in, okay, then it delegates to press add insurance. But where the linkage is, what does it mean to add these subdomains? You will get, when you go through a name resolution, you will understand. So these are just some information. You should know them. So what should be the syntax of this name? So theoretically, you can have any number of words. DNS does not specify that at most 8 letters or at most 10 letters or something. Only thing is, each of those somethings cannot be more than 63 bytes. Okay. And the total, usually almost all implementations, you understand you cannot make it infinite, restricted to 250 bytes, including the dots. But within that 255 bytes and within that maximum 63 bytes restriction, you can have 100 dots. So I can have and as I said, absolute names are names that end with dot. Relative names that does not end with dot, meaning they will be completed by appending something at the end. So you don't want to type everything always. You can configure to say this is my relative thing. So anything that I say, if I don't specify the dot at the end, add this to later. And nodes can be, you will see these domains of host instance also. That's kind of more the syntax. This is a concept that is important to understand. Okay. And think with me. I don't want to use the word because online people will use it. So domain, so you have a tree structure. Okay. Normal tree assembly. Any number of children are possible. Okay. So a domain is nothing but a subtree of this DNS. Okay. So you think about the tree, you look at any node out there, take the subtree. On that node, we'll have a name this, dot this, dot this, dot up to the root. Okay. So that's my scheme. Okay. So domain just defines part of the namespace. I'm kind of cutting off saying that this is the subset of namespace. Whereas a zone, it's a subtree for which the naming authority has been delegated to some server. So it's a big name, we'll see what it means. Okay. But what this means kind of is this. So think, okay, that I have a domain that starts with X. Okay. And I have two children of the X, Y, and Z. Okay. So and then there is the children of those also. So my domain will include the entire subtree domains. Okay. But then if you think of the domain y.x and z.x, okay, I can have the z dot part cut out as one zone and the rest of the things as one zone. What is a zone? You will understand it. The zone is the one that will actually be important in doing the name resolution and deciding who will take care of this and so on and so forth. So domain is just a namespace. It's just very simple to understand. It's a subtree of the complete tree. First of all, remember that entire tree is basically one complete tree. The set of all possible DNS names in the entire world. You cannot go beyond that. Take any node, the subtree below it is one domain. Name of the domain is that node, dot this is all the way to the top. That's why you pick the dot because root is the Now within that subtree, you think that I carve this up. Okay? And the rest of the part, whatever the shape of it is there. And I say this is one zone. Okay? And this is one zone. And then I will say this zone's time resolution will be done by that server, and this zone's time resolution will be done by that server. How that is done, we'll see. Okay. But it's important to understand the distinction between a domain and a zone. Okay. Is it clear online? No, can you hear?
Yes, sir.
Yeah. What was the question?
Domain is clear.
Domain is very simple. So now think about domain. It's this kind of like this. So you just think that you went 3 levels. Your person knows now is there. Think of it. Okay? So you know how to do this. Think of that way. Let me just cut out one part of the tree. So one triangle out of this entire triangle. Okay? And I'm saying this triangle is one zone.
That's also subtree.
That's a subtree. But then I can even cut from there also. Okay? See, I wish I had a chalk at first. Okay, this home shifting is going. Anyway, I think we'll understand. We're very good students, so let me try this. See, you think about a 3 element. So everybody has 3 children. Okay? Now, the rightmost children of the room, that subtree I cut. Okay? Then the rest that is there, forget about that subtree. The rest that is there is not really full subtree. It will be a subtree, it will contain some nodes. Right? So, I am saying it's possible for me to do this, that only the subtree rooted at the third child of the root. Okay? Enter all these nodes. These are the names. So somewhere should be somewhere I should be able to say that name and get the ID for it. Okay. I am saying that's one zone. And that name server will see how to do that. That name server will have authority over this zone. Because if I want to do any name resolution for any name within that subtree, I will ask the name server. Now the remaining part I can say is a trace. Okay. Now these element doesn't have to be this nice triangle of the right hand side. This can I can break it. So theoretically I can have, theoretically nobody does that. Almost every node out there I can say different. But that will be doesn't make sense. Okay. So we'll see how that is done. So what are name servers? It contains mapping information for one or more zones. So now we start using the terminology zones. So you don't really technically do name translation for domains. Okay? You do name translation for zones, okay? Which can be the complete domain or part of the domain that you practice. Give me 10 more minutes, I think you will understand. So maps names to IPs, which are called forward lookup. So to be called a DNS server, you must have to do forward lookup. Otherwise it doesn't make sense. But most DNS servers can also do the reverse. You can give an IP address and get its domain. But then that domain name is something different. We will not do this. It's kind of there's this domain called arpa.addr.ip.addr.in or something. Okay? This is kind of mythical domain. So everything will get mapped to that. Okay? So then so let's not do reverse lookup. Just remember that you can also do IP name. The name to IP lookup is our focus here. It is the primary purpose of a DNS. Okay. So name servers obviously don't want one, okay, because if that goes down, then all your name resolution goes down. So you want more than one, both for fault tolerance as well as for load balancing. And you have a primary and secondary. Concept is very simple. Primary is the one which contains primary copy. That does not define anything. Because it's saying the primary name server is primary copy. It's the only modifiable copy of what is called a zone file. So a zone file, I'll show you the format of a zone. The zone file is like a text file which will contain all those maps. So when you ask a name server name, what it is doing is just looking up that zone. And it will have the names in the zone file for only its zone, which is, as I said, it's a part of the domain base. It can be the whole domain or a part of it. Okay. Only single modifier will copy of this. But then you will have secondaries because you don't want all the requests to go to primary. So you will have secondary name servers. They will periodically include the zone file from the primary, which is a name or zone transfer, and they will answer queries, but if you want to modify, you have to go to the primary. And if you, this is a little bit of vibration, but your so much of your data access, including almost entire database, theory of database and all, parts of the principle that reads are much more frequent than writes. If that does not happen, yes, almost everything performance will break. Has to be completely break down and database indexing will break down. It's a dedicated index only times. The same concept here. And basically, you say that, you know, how often do you install a web server and take it down again and then install something, change its IP? It's usually going to be there for some time and then it will change. So whenever you change it, has to go to the primary. And either a primary or secondary is called authoritative server for example. These are names that, if you understand DNS, you should remember. Who is NS Kuta? Okay. On your Linux machine or Windows machine, NS Kuta, clearly get some IPs and all that. You will see sometimes non-authoritative names. So which means it is not coming from the primary or secondary for that. It may be coming from a shared cache, for example. I got it from somewhere, but it's not somebody who has a zone file. And the zone file is going to be only in the primary or secondary for that. So I have to designate that, load the zone file, configure the zone file from the primary. And we will divide that some format of the zone. And remember, a server is just a server. Okay? And so you can actually have multiple zone files in the server, which can be primary for something. So that file you are able to modify. These files you are write only on the source code, which means it's primary for some zones, secondary for other zones. And the same thing. Because it's just using the physical infrastructure to do the same thing. Is it clear? Primary, secondary, authoritative. Okay. Note that when you do data configuration, you have to configure your laptop desktop level. Okay, what you said? You remember? When you are 30 years, see, think a little bit. See, everybody is so busy developing software, beautiful applications, all that jazz, nice colors, okay, and they're very important. That's what most of the uses. Never forget that you must have a system in the back end that runs it. The system is so complicated that even this top of the iceberg is. And the other thing I remember the first class, and I like that answer. We said that we are not going to do much of wireless. And somebody in the class, I said, do you think it is right or wrong? Somebody in the class said, no sir, wireless is everywhere. In most cases, wireless is still that access. That access. Go beyond that, everything is fine. For most cases. Yes, even data centers have wireless networks. But that's only the limited. Almost everything else, when you have to run, where from router get DSL installed, you have to wireless. Yes. Other kind of bandwidth. Okay. So you don't remember what do you think you need to say? Think of your machine and online with recurrence answer. Okay. So if you want to set up your got a new machine, you want to access the web. What are the things that you need to set up your network? Huh? If you install a browser, that's not going to work. The browser is not going to do your network configuration. and say, okay, I know what's why you say that. Okay, you don't have a DHCP server. Because typically will show the DHCP client will start running, the system will automatically run it. You'll find out the DHCP server, everything gets done for you basically. Okay. But your CS students, mechanical student can say that. Okay. एक तो चीज बोलो यार. What do you need to access a network? Almost the course is over. Tell me one thing that you need so that your machine can go to the net. What do you need to continue? What OS needs to do, OS will always have. Okay? उनको क्या करना है? IP address at least तो बोलो यार. Okay? I think last of order network around travel. After teaching you one semester of network, you cannot say that I need an IP address to go to the network. Okay? What else now? Now that it is IP address. Number is application. Or yeah. Subnet mask. What else? कुछ नहीं पढ़ रहे. क्लास में करा. You just try to trace. That is why it's important to trace that time. You will know what to do.
There is also an option to configure DNS servers.
You must configure DNS server. You cannot use www.google.com. But strictly speaking, you are right that even if I don't configure DNS, I can go to the internet, but I have to use DNS. But you need one more thing. You can go to the internet. Typically, other than IP address and subnet. I am not going to let it go. Okay? Don't go back. So tell me, go back to IP. Okay? Your IP layer packet. Otherwise, you are going to do horribly in this. Let me tell you one thing. Okay? EX is a special grade for you. EX you have to earn. A's and all are much more lenient about. Typically, my course online, I have given enough EXs. Okay? Because unfair, if somebody works hard and somebody cheats and so on, we cannot distinguish and all that. But typically in my class, there will be 5-6 EXs. I have no problem giving 50 EXs, but you have to earn it. And this is not earning it at all. We are not earning an A also. So tell me, let us take that dot discourage you from coming to my class tomorrow morning. Okay? Don't worry. It's not that I'm going to say, no, seriously. You have an IP address. Okay? The packet has come to you with an IP address, destination IP. What do you do to forward it? Basically. What is the first step you do?
ETL.
Huh?
ETL. And you are talking at the IP level, right?
IP, yes.
ETL, right? Absolutely. ETL.
What is PDA?
Time to level.
Okay, fine. Assume those things are there. I'm just saying that finding on the kind of the path. Yeah.
Sir, we check the protocol.
Go ahead. Go ahead, we can hear you.
So we check the protocol. So depending on the protocol, we might pass it say TCP, then we pass it on the TCP stack. If it is
TCP is not at all. TCP is above IP. First, my IP layer packet has to reach the IP layer at the other side. IP doesn't see. TCP needs IP to do all the pseudo header and all those things. IP does not need ports to anything. Yeah.
And also the routing.
Yes. Forward is what? See, if I say you have to forward the packet, and you start talking about the routing table, what is the talking about? Okay. What do you do to forward? So, how do you use the routing table? I got a packet at the IP layer with a destination IP. Now what do you do? What's the first step?
Mask it and set.
Right. So you look at every routing entry. Every routing entry has a subnet mask. You do a bitwise AND. You take out the network part, compare it with the network part. Okay. See which ones match. What if 3 of them matches?
I guess.
Take the longest prefix, the one that matches the most. Fine. So now, that entry, what does that give you? You have got the longest prefix means. What does that give you now?
It will give us the next hop.
It will give you the next hop. Okay? So, if it gives you the next hop, let me go back to our earlier question now. So, from here, let's forget about nagging and all. Suppose they are all public IPs. And you said, sir, you are sending a packet to somebody in US. What is your next hop? Somebody has to set the routing table entry, right? On your laptop. It's done by the system when it boots. But the parameter is supplied by you. It's the gateway. The gateway is basically every subnet must have an outer basically it says that it's not within the range of requirements. For your laptop PC, if you have a main machine, it's very simple. It's like a default rate. It's not within my network, I don't know where in the world it is, I just send it to the network. That's the third thing you configure. You must configure IP address, subnet mask and gateway for your system to be enabled for network. Typically, you also configure the DNS because otherwise you cannot use these. So let us finish that thing. You have enough time. Now what will happen? Now you got the next stop. It's my IP. What do you do now?
Now find the MAC using ARP.
Good.
If not already there.
Okay. Find the MAC. How do you find the MAC? You don't answer. So how will you find the MAC? Huh?
So ARP packet.
Send an ARP. How do you send an ARP packet? So ARP header has a specific format for ARP header and all those things.
Sending it with the broadcast.
Right. So you encapsulate that in Ethernet frame with the broadcast address objects, basically. Okay. And then somebody responds. Now you got the MAC. Now you put that MAC as a destination MAC, which is the MAC of the next hop, and you send it to the next hop. Follow the packet. If you can set the just think of that you made a send call, you make a receive call. Just think about how we are going to fill in every header field. Okay, that's what I'm going to do. I'm waiting for next week. Okay, see all this I'm saying just to say that when you set the DNS, you will see typically there are two phases: primary DNS server and the secondary DNS on your client side. Okay. All I wanted to say is that primary and secondary that you see when you configure your network has nothing to do with the primary and secondary that we just described as well. That is basically just saying that here DNS resolver, your client program, which one does it conduct first? The primary will conduct first, and if for some reason primary is down or something, then you conduct the secondary. So primary and secondary DNS servers are used in different contexts. In the context of the DNS system working in the backend, the primary is the one with the modifiable copy of the zone file, secondary is the one which is copies. You can answer queries, but you cannot change the zone. Whereas in the context of a client configuration, primary and secondary are who you contact first, who you contact next basically. Okay, before we do the servers, somebody has to start. Okay. So this dot actually, the dot is called the root zone. Just the okay. Not having a domain. So that's why you are saying the zone. Just the dot is one zone. It's the root zone. Okay. And it contains name server for all top loaded domains. So let's just think about .com, .gov, .in. Just three top level domains. So let's similar things. Okay. So dot will just contain the IP addresses of the name servers. Can be one, can be more than one. Okay. Of these three zones. You will see that zone and domain will in fact kind of use interchangeably. It's kind of confusing. Go test course lines, anywhere you see, kind of interchangeable. But when I show you the zone file, you will understand what the difference is. So you have to start somewhere So every DNS server must have at least one root server. Idea is, now it's very simple, don't look at the slide. Okay, if I don't know anything, I go to the root server. I know I want to say a.b.c.com. I say I don't know anything, give me the name server IP of com. Okay. Now you go to com will have the name server IP for c.com is. c.com will have the name server IP for b.com. Okay. So nobody will have the entire thing, but everybody will have something. If it cannot resolve it, something that can redirect it to who can do it. Everything? Okay. So these name servers are called, there are 13 root servers, but A.dot root servers or B.dot root servers, K.dot root servers are named. These are well-known IPs, publicly available. Okay. But then 13 seems to be very good number. And you are absolutely right, it's not 13. There are actually 13 advertised IPs, beyond which, for each of these IPs are backed by likely hundreds of servers controlled by different organizations. Okay. Now, how that happens, one IP to many IP mapping is kind of the same thing where we talked about in Google List. You get one IP, but that one IP is not one IP. It's not in the syllabus. If you care to come in the last class, and this facility will be done. Yes. Okay, now we have all the ingredients. Oh, that is all. What is just the name? Okay. The DNS client-side program, which is the name, it's called the DNS resolver. So gethouse by name, we are calling gethouse by name, it's the resolver, you're calling the resolver to get the IP. Okay. So what is the name resolution? Now that you know all the pieces out there, primary, secondary servers, root servers, all those things. Each domain's name server must contain the name server of any server. So root servers will contain the name servers of TLDs. TLDs will contain name server for their subdomains, and then further down. I'll show you an example. So name resolution process simple. If you don't know anything, contact the root server. Okay. So you have the name that you want to resolve. Look at the last part. Go to the root server, say give me the name server for that. Now that will give you the name server. Then equally that name server will say give me the name server for the next one. And so on and so forth until you are left with nothing. And the last one you say give me the IP or whatever, depending on the type for that last one. So either you find it happening or maybe you have typed a long name or there is no machine out there. In this case, we will begin. Okay. Is it clear? So how can you, does it look good? Is it good? It's a good scheme. नंदा मेरे मुंह में कुछ आंसर नहीं है.
It's slow.
Try. It's very slow. Why is it slow? First of all, multiple forms. What coming in? Can you please repeat?
Lots of requests.
Lots of requests, okay? And you always start at the root side. But you think that from inside, let's say I ask for www.google.com and let's say my DNS server goes nothing. Okay? It was a root server, got www, eventually did this process, got the IP address. Next, somebody has www.yahoo.com. And these are completely two separate machines. But there is something common, the .com. And in the process of getting www.google.com's thing, I knew one thing that I can use. What is that? The name server IP of .com. So I no longer need to start from dot at first. I don't need to go to the root server. I can directly go to the .com server IP and say, give me Yahoo's name server. Then I will go to Yahoo and I will say, give me www.yahoo.com. And you understand, if you have very popular sites like Google.com and so on and so forth, okay, over a period of time, your cache kind of builds. So you don't even need to go to even .com backend in this case. So standard answer to all these performance questions, you cache. Okay, so this is something that I just told you. I think I'll come back to this. So starting with root server always increases resolution time, increase load on this. So you cache. Okay? And you always look up in the cache. There is a cache at the client side. It doesn't even go to the DNS server cache. Okay? There is a cache at the server side. Okay? And you are going to cache things out there. There are servers whose sole purpose is to cache. They are called cache engine servers. They are not oriented for any zone. They don't have any zone. So if you query them, they will always ask for this, but then they will cache. Okay. The last interesting thing before we go to resource records, and after that we will do it. So give me 10 minutes. Okay. Is so you see, I'm the client. I ask a DNS server for a name. Okay. I expect an IP. Right? That's not what my goal should be. But then instead, the DNS server is telling me, no, I don't have it, he may have it. So I have to do this thing. So you have two options, basically. One is very good for the final end user, is that you ask the DNS server, okay, and the DNS server does whatever is required. Go to root, whatever, cache, etc., etc. Finally gives you either an IP for whatever you asked for, or it gives you an IP. The other possibility is what we just described. It says, no, I don't have it, but there is .com name server. So I go there, say no, and I go there as well. So the second one, where the client, okay, is expected to go to each server separately, is what is called an iterative query. Okay, whereas the other one, where so I will ask basically .com to give me www.google.com. So then .com will ask Google, give me www.google.com, then forward that to me back again, basically. Are you with me or not? Yes, no? Okay. Queries can be two types, recursive queries or an iterative query. In a recursive query, DNS server either gives the mapping or forwards the request to the name server that may have. So if I forward to you, you are the DNS server, you don't have it, you forward ask somebody else. And then this will give the response back here, and this will give the response back here, this will give the response back here. Whereas iterative, you will kind of remove the responsibility very first thing, I don't have it, you go ask. And then you forget all about it. Then I will ask the other one, he will say, no, I don't have it, Google has it, this is an name server I can do. Then I will go ask Google and so on. So the job is on the client side basically to actually go ask everybody else. So which one is good? What are the pros and cons? First of all, to know which one is good, again in design there is hardly any answer that this is universally good, this is universally bad. Nothing. Okay, you just get a final answer back. What is the con? Do you make more number of requests? Not really, right? Either you are doing this, or you are doing like a flower out here. But the same number of cycles, right? So you don't really make more requests or more messages. So what can be the form of recursive queries? Okay, what's wrong with having responsibility? Now that's what the survey question is, okay? Okay, more than memory usage, because I can always, okay. Resource aside, okay, the intermediate server. So think about recursive query. A has sent a request to DNS server B. Now B has sent to C, C has sent to D, and so on. Throughout this time, until the response comes back to B and B gives it back to A, B has to remember about A's request and remember it as sent to C. Now this is one request. The DNS server is going to get a lot more requests. And if you have a lot of state, that is not just memory, that's also looked up because when the response comes back, you have to map the response with the corresponding state. So you need more resources and then it comes to it. Iterative, you don't know it, you look up your zone file with the name server, give it, or you have an error, say I don't know it, and you forget all it. And the client is just one client handling few requests, basically that can maintain each thing. So that's the form of recursive query, and obviously the form of recursive over iterative is the flow of iterative over recursive. But then finally when you go, you have to decide which one you have to use. What do you think? Again, there is a universal yes to answer. But just from a spirit point of view, to record a DNS server, you must implement the iterative. Recursive query, you may or may not. Mostly do, mostly configure. Yes. But the code is always there. That is very simple. If my server is not doing much, I can afford to maintain this. If my server is busy, I cannot afford to maintain this. Okay. So, who are the busy servers in this DNS server? The one closer to the. Okay. So, as you go up, recursive becomes active. So, your PNE servers will always never do recursive. Even most top level servers out there will never do recursive. But because so much traffic is passing through them, that then they have to remember too much space. Very simply not possible. 4 or 5 slides before we take a break. I won't start anything new today. 8:21, but no, it's just 1 hour of class. So I will start something new. No, we're kind of tight on time, and I want to do, whether you want it or not is a different issue. I want to do something beyond the core set of all interesting concepts, just to kind of hopefully start something in you to think about later. Okay. So your zone file will have what are called resource records. So now we are coming to that format of the zone file. Okay. And this record, so these are the types. Each record will have a name. Which is the name? Will have a type. Is the type that I am talking about. It's a string. Okay. Will have a TTL. It says how long is that in value unless it is refreshed. Okay. And RDI is resource data that will depend on what are things. Don't worry about it. And here are some of the common resource types. SO is a special type. It kind of identifies the beginning of the zone. But rather than if a name has NS type, means that name corresponding to a name server. A and 4S are host name. A is an IPv4 address. 4S is an IPv6 address, basically. NS is for mail server. CNAME is an alias name. These are these services. Look at an example. This is an old, I think of typing my own, but then I told what I got from one of the old sites I have for something. So you see, so this syntax can vary a little bit here. So the $TTL3D, it says the default TTL of any entity. If I don't say anything, 3 days. Okay. So after 3 days, this zone file will. So think of the second value for example. After 3 days, this will cease to be valid. But default TTL file changes. This one is a simplified. I remove certain things. So first line, this is start of authority. It says it is the zone file from the domain mc1.land5.com. Okay? Sorry, I'm sorry. Land5.com. And mc1.land5.com is the name of the primary name. So that's the problem. You have to specify in the first line of the SOA the primary name of the domain. Okay? And the root of land5.com is actually email address. Root at land5.com. who's the administrator who is responsible for this? Panel administrator. So this is the zone file for land5.com. Okay, but here give me one more slide, and then you will see that interest between that is not the entire land. Okay, that is domain versus zone thing we coming to this. Then you have this page looking number, which is serial number actually. Okay. So 1996-09-26 says basically 20th September 1996, and this file has been modified 6 times on that. So every time you modify it, it will give us a name. That's kind of fast. So when you have secondary tools from the primary, okay, you compare this to serial numbers. If the serial numbers are the same, they don't need to. Nothing has changed. 8H says how fast will secondary spool the zone file from the primary. So we have to do every 8 hours. Now, if they try to do every 8 hours, but cannot because the primary is unused, then they will retry every 2 hours. Now they will try faster, not every 8 hours. Okay. How long will they retry? 4 weeks. You can set this range. After 4 weeks, you will give up as the primary. What happens after that is up to the administrator. So basically, they have a DNS system and nothing is modified. So administrator has to come and update one of the secondary time. What's your mistake? One day is being on TTL. So NS, so this two basically says are the two name servers for this domain. And you see, ns2.psi.net is not land5.com. It can be. But it will be considered so that in the send a query for h.land5.com it lands. The two MXS basically says that mail.land5.com and backupmail.land5.com, these are the two mail servers. Note that they don't give me any IP. None of those mail servers or the mail servers are giving me any IP. TXT is just a definition, description. Now you got the array, which is the actual host name to IP. So you have a sum of condition, router, MC1, MC2, mail server. Okay. There will be backup mail and all should be there, not included. And now, so FTP CNAME mc1.land5.com. What does that tell me? The CNAME is an alias. So it's telling me, note that it's FTP. Notice mc1.land5.com dot. That is the mail server FTP means no dot at there. No dot at there, I will just append land5.com. Okay. So this is basically saying that ftp.land5.com dot is just another name for mc1.land5.com. So if you connect to, if you say ftp.land5.com, it will actually go, see it's mc1.land5.com, then you go to the subsequent you find the area of that and give me the IP 206.6.177. So I can have multiple telnet dot something, ftp dot something, etc. Okay, running on the same machine. But then typically that's not good to ftp dot something, telnet dot something. This cannot give me a name that the user is able to remember. There is the zone thing comes in. Similarly, www. The www.land5.com is actually running on that two machines. Next was serve record is equal. Serve record actually says about the current. So telnet.tcp serve basically means that there is a TCP service running called telnet. Okay, running at the port 23 of machine MC to the land5.com. So now you can discover services that are running on your things. Right? Do not know whether this land5.com has a telnet service or not. Okay. I can actually query for telnet or something and look up the server record and tell me that this report is things. But here comes the zone thing. Now, out of that ns1.subdomain, sorry, land5.com, I kind of take out subdomain 1.land5.com. I don't know your name. This is the domain versus zone thing. Okay. So the entire thing is land5.com. And I have a zone file contact. But then I'm saying subdomain 1.land5.com is a separate zone. We'll have a separate zone. So none of the machines with something.subdomain1.land5.com comes here. So I've kind of taken from land5.com domain, okay, two chunks out, subdomain 1.land5.com, subdomain 2.land5.com. So I have three zones created out of the same one domain. And then I'm saying, where are you going to find the information for them? If you get a machine called A or subdomain 1.land5.com and you query this one, you say, I don't have it, but here is the name server for subdomain 1.land5.com. What is the name server? AS1.subdomain1.land5.com. And I have an AL call for that. So I return 202.122.122. But I don't have them because that machine will have the zone file. Similarly, an SOA for ns1.subdomain. So each system will start with SOA ns1.subdomain1.land5.com and some administrator email context. Yeah.
Where is it implicitly mentioned that .landfi.com should be added wherever this block is?
That is because the landfile.com's this thing. So, see, this is the SOA of the next root.landfile.com. It's actually root at landfile.com. Okay, so I know the landfile.com is my domain. So if I don't specify dot, it will be by default. You can also configure. There is a dollar directly, if I remember correctly, by saying that what is it that you want to become? And it's like for API. It is just a way of typing this, that's it basically. Okay, forwarder you can read yourself. So these are kind of, I don't think it's important for you. We're almost there at the end. Runs on again UDP port 35. It's an application layer protocol, nobody calls it. It's a necessary protocol to make. Your layering is in principle nice and it works 99% of the time, but these are the places like this which are more distant. So how do you send? Here you are designing the DNS, you have to send the packet from one to the other. Okay, fine, you need an unreliable service. That's all. How do you send it? Either you can send it in case in the IP packet, but then you have these nice sockets and everything is easier to write on top of that rather than create the IP header and all these things. Just use it. Message format and all these things not important. Reverse lookup is not important. And finally, just remember. So I will tell you what is important for exams. Okay, not all these things. So simple DNS. Let's say one modifiable copy, and typically you will modify it in a mobile hand. That's simple DNS. But that's cumbersome. And if DHCP what happens is your web server will also get an address from DHCP. When the address changes, it automatically get DNS. So it's a protocol called DNS. This is a lot more the security authentication. So, what we want you to remember, because that is at the end of the course, we want you to remember the basic definitions. All this, what is a domain name, domain versus zone, primary, secondary, authoritative, basic name resolution process. Okay? We want you to remember that there is something called a resource record and something called a tag. The format is absolutely not important. We will not ask you anything regarding the format. Okay? Message format is completely out. Nothing. Dynamic update of that is also not included. But you should know otherwise not completely. The exam has basic derivation at the beginning and basic derivation. Okay. Do one thing. Take a break. Today I want to show you something also. When you come back, I will decide whether I just start something and finish it tomorrow, or I will just show you. Show you that we also got more questions, but I will tell you. Not take a break. Huh? So small 5 minute break online. Then we'll come back. Okay, so let's get started. I forgot to unmute, but anyway, we have not started yet. So as I was saying, I will do one more application layer protocol after this. Tomorrow or maybe I will use the board and see. Or finish this and then we will start. But application layer protocols are not very interesting. Well, they're interesting, they're very useful, but teaching wise, different protocols and different things we will not understand. So last interesting thing that we do is DHCP. Again, I will not do message formats and all fully, and there will be things that we do but not in the exam. I'll find them out. But nicely, as Nisha just told me, so I never had to do something. Magically, and this is start to work. That's what happens for almost all. Because what happens is typically if you have DHCP enabled, your system will automatically start the DHCP client on boot, okay, and get an IP for it. Lots of time it has an IP, and then something else happens basically, but you don't have to do anything. But then, if you think a little bit inside, this is very interesting question. Think that you just got a completely new machine, no IP, nothing, enable DHCP, you connected it. Okay? So the client is going to ask the server. Okay? First of all, how does the client know where the server is? Who is the server? And second is, even if it knows who the server is, how is it going to communicate? Because so far what we have seen is that for a client and server to communicate, both sides must have valid IP. So how do I communicate using IP when I don't have IP? So let's get to the first question first. So how do I find out, okay, the DHCP server? Can you think of anything? You have done something which is there. On a normal semester, not this semester, this is a good example. So the think of this as a broader question. Okay? There is a network, there is something that you are trying to find, and you have no clue where it is. Okay? That's the big question. If you don't know where is it at all, what is it that you do? Broadcast. Exactly. See, you know the answers. You just have to think. Okay? So I kind of broadcast will send, I want this, who is going to respond? And I will do broadcast time. Okay? Now, to send this, you are in a source cycle. Just to send a message. Because the source cycle is never used in forward. Finally, just put something 0 something. But why is there a problem? Because the response has to come back. Who is it going to send? Okay. So let's look at it. So it works like magic. It's a beautiful, simple protocol. It actually has a long history. Okay. So old days, you had what are called this workstations. This was very costly. Okay. So you have workstations which are nice small computing things, okay, with small thin clients and other things, but they do not even have the OS sometimes. It depends on how much money you give. The basic ones don't even have the OS. So on boot, basically there is something called a boot P client. Okay. So the client software is there on the firmware, it will start up and do this thing, DHCP like thing. We actually download the boot file and then boot from there, and we will see your Linux screen out there and so on. So you have to take a very small bootstrap for example. You get the IP and everything. So that was the genesis of this, the disk-based workstations. So RARP is the reverse ARP. Remember, reverse ARP is that you get your hardware address, you get an IP address. That's what it is. But it's very limited in scope. That's what it is specific. So RARP was never not too much use for this. Boot P was a protocol that was designed for it. So DHCP is actually compatible with boot, but no one uses boot P anymore. Okay. So boot P was a very strong protocol, and whatever I'm going to talk about DHCP, many things hold for it. But the only problem is there was no dynamic IP approach. What is meant by this? So think that we have this 100 display source machines, and on the server, each of them has a network card. How you cannot communicate anything? So there is a NAC. On my server, I have a mapping already made. This MAC ID is this ID, this MAC is this ID, this MAC is this. It's a fixed MAC. I cannot change. So when that workstation puts up, it sends me its MAC ID. I look up that table and say, oh, this MAC ID, this ID is sending that. It's a fixed set of things that I reconfigure for every display workstation. So I can't change it. But typically what you want, think of the other extreme, you are at a conference. Okay? What do? You go and take your laptop, okay, it starts to work. Why? Because again DHCP. So when DHCP gives you an address, it comes to you, say your machine is using that address. Then you go off at the end of the day. Next day there is another conference with another set of machines, with another set of MAC IDs. Now, if I had hard-coded your machine's MAC ID is that ID, then I have to manually change that at the end of the day. Make sure the next lot of files coming to the next conference will actually get done. So there was no dynamic ID and a fixed thing that you can do all this. So DHCP solved this problem. And the interesting thing about DHCP is it tells you use DHCP normally to get this IP, subnet mask, gateway, DNS. I can give you almost anything. You can configure a DHCP server to give you almost anything that you wish, any parameter that you wish. So book file server is to be very good. So the DHCP server will not give me the OS image. It give me the name of the server, which I will then contain an IP. So now I'm fully configured. I'll contact that to get the disk image of the OS and move forward. Anything, book file image, client server, domain name, host name, executive server, POP3, you name it, you have. Anything that these server things that you need to know. But typically we use, you will see most people IP networks. Now there are gateway DNS. It also runs on Unity. This server on Unity port 67. Very interestingly, client IP is on port is also fixed. That's something that you don't see, right? Client is not anything. This should start in antenna. Why is it fixed? Now no one answer it. This should start in question. You will not write that. Don't write. Maybe at the end of this slide, you will. What is the question I say? UDP, you are saying it uses UDP. UDP is encapsulated in IP. Okay? IP header will need isource IPs. How can a device use UDP before it actually gets it? And that's what I told you already. So at least for the first message, I can always say source IP 0.0.0.0, destination IP all once. Okay? At least it will go somewhere and reach somewhere. And because it's broadcast, it reaches the IP header of the UDP. Now the DHCP service is port 8067, then it will be given to UDP port 67 software. That is DHCP, DHCP will know what to do. I still have the problem of counting in practice. Okay. Motivation, lot, move a machine between networks. I am understanding this. Why you have to configure everything? And DHCP, if you take your laptop and connect it here, there is one side. Go to the hostel, there is a different side. You don't have to do it. This as you move from network to network. You add it to the machine, don't have to do anything. Like the conference example I said, reclaim unassigned address space. In all these cases, configuration should be simple and automatic. That's the unfortunate part of simple and automatic is you see students don't know what is happening. Remember, somebody will have to write the DHCP. And this one is beautiful. You can tell you a couple of commands that you can do on your laptop when you are connected. I've shown you that Wireshark. Please run the Wireshark or do those commands and see this message is going to I'll come back to this. We'll do it tomorrow. So we'll do what is understandable. This is kind of a broad set of things that happen. Client will send a DHCP discover message to DHCP. Again, it does not count, so it does not count. Server will reply with DHCP offer with some parameter saying this is the IBM offer. If the client accepts, client will send a DHCP request. That sounds odd, right? So that's it. Then server will connect the offer to storage, send a DHCP ACK. If any problem, don't connect and send DHCP ACK. Client starts again, client checks again. That sounds odd, right? What is that to check? It accepts nothing, it comments and DHCP decline. And anytime you can release nothing. So this command I'm saying, I'll tell you command to release your DHCP ACK. And then get it. So you should see the release message going and then should discover all these things happening in this. But I'll end with this slide because there's a lot of things in this slide. So first one is how do you send to the DHCP side? And your answer actually that you will put all one IP address. Destination address. All one is what is called a limited broadcast address. What is limited broadcast? It will broadcast to all machines inside the subnet. You don't go past the subnet. So no router will pass from one subnet to another and all one address. Why should the routers not pass it? What is the harm if the routers pass it?
The machine is asking for an IP.
The answer to this is not in DHCP. It says so limited broadcast, all one addresses are never passed by routers from one subnet to another, irrespective of what protocol thing it's there. Answer is trivial. And it's a long class, but yeah. No, all one address. Subnet part is constant, you put all ones, let's say that's a subnet specific thing anyway. Okay. So it's kind of the same. It's all one is theoretically everybody. Okay, but I'm saying routers will not pass it beyond this subnet. Because just think about the damage that you can do. So beyond the subnet means what the entire internet is. All the routers keep on passing this thing. All you need to do is to sit in your corner and just start generating all one broadcast addresses. Okay? And I have never passed the society is done, we never passed beyond it. But then it's everybody in the system, basically. The server replies with DHCP offer. Okay? Now that part is a very complicated. Whether how you will route it back, okay? I may or may not do it because that requires me to go into the format of the message. We'll see. Okay, but I assume that it can come for the time. Let's think that I will zero back. Now, why should not the client just accept it? Send the request, response to you. What is the problem in just taking that I will got you? Why does it have to say request again plus? There are more than one DHCP servers on this. Both of them will get, both of them will offer something. You have to choose one. Mind that I understand it's a long class, end of the day, but all I'm saying that is one thing is to just we can go through these messages and know the details. Other than that, you can start trying to design a DHCP. You can see what problems you will get. So I may get more than one. Suppose I got more than one, I choose one and I send the DHCP request. Now that destination IP I know. The server will tell me that message, what is my IP? I don't need to do it. I still do it. You know, I kind of guess right. with something in the message saying that I have chosen that. Exactly. So the other server, because the other server is communicated and it knows that I am not going to get it from you. So you can give it to someone else.
But in any case,
Always will wait till the time out and it just goes in order. That's it. So, but anyway, standard associate standard time. Typically, AHCP will send it to the broadcast timing. Okay. So you get now you are kind of talking to the AHCP server that you have chosen. Okay. Now the server will commit the offer to storage, send AHCPR. Why should the server have any problem and not commit? I have told you I am going to give you 155%, 10%. Why should I come back and tell you that no, I cannot do that?
multiple machines asking for
Right? You see, you are getting all that. You are designing on this. And then OLAP equal, and this what information need to be carried just like I said, that the AHCP request should tell the other server that this server is chosen. Which means somewhere in your AHCP message format, you will have to choose one field for that. So that's how you design your things. Or you can mark it. Yeah, very much. Okay, good. So the server may have got a request from many people. You do not know what the server time of is. Maybe you are late. The server can go on. The server will tell you that I cannot do it. What is the time check again? This is a little what class. Now the server is telling that no, I am still being accommodated. This is more to see any misconfigured DHCP and all this. So, if you have multiple DHCP servers, typically your DHCP pools should be set. Two servers should not be giving out the same pool of addresses. There should be distinct addresses. But somehow because of misconfigured or something, okay, and this server is given the same IP to somebody else. That's one instance of volume system in DHCP. So, you check once basically when trying to send a message whether it's an IP config or not. There are a couple of error cases like that. If they all pass, then everything is fine. So server is committed. Server is not expecting anything. If you don't say anything to the server is given that. But if you don't want it, you say it. And then release, you can release at any time. To stop here, I don't think anything else is going in. We start from here and look at a little bit more details about each of those systems. But all I'm trying to say is, is this piece of code that somebody has? What is that also? This is a piece of code, and then you can start designing your own protocol, your own data center. You just know what is the requirement, what is the basic network you need. Okay, any questions? Anything from online?
No, sir.
Okay. So stop here. We'll come back and finish it tomorrow. And tomorrow I may use the board a bit. So those of you who are online, you may need to get pictures from your friends and so on. We'll see. I'll try, kind of. We'll see how it goes. Okay. So I'm going to end the class. I'm saying not sure. Sorry. Yeah. I was thinking whether to tell them this or not. So, subconscious tell me. Now, so 4 of you online. So I'm going to show the class here. Don't worry, not too many of them are here anyway. So something are interested, contact me and we'll take care of it. Okay. So otherwise I'm going to stop this sharing and all, and class is dismissed. We meet tomorrow at 8:15 again.